Determine the distance of the point having coordinates 2, 5 from the line 3x plus y plus 4 equals to 0 measured parallel to the line 3x minus 4y plus 8 equals to 0. Okay, let us begin. First, what we'll do, we'll try to understand the problem graphically. So here we have the point A with coordinates 2, 5. We have the straight line, let's call it the line L, whose equation is given as 3x plus y plus 4 equals to 0. Our goal will be to determine the distance of this point from the line L with a condition that when we measured it from the line, let's say we join point A and the line L, meeting it at point B. So we get the line segment AB. Now we have to find out the distance AB with a criterion that this line must be parallel to another line whose equation is given to us. So let's call this the line L prime. So L prime has the equation 3x minus 4y plus 8 equals to 0. Okay. So our goal will be to determine the length of AB. Let's denote it by the letter R. So here what we'll do, we're going to use the distance form of a line. Now the distance form of a line is given by, so let's say if we consider the coordinates of point B to be x, y, then we can use the distance form of a line to represent the equation of the line AB. So that is going to be given by, we have x minus 2 divided by cosine of the angle alpha. Now cosine of angle alpha is simply the angle that the line makes with the positive direction of x-axis. So this is going to be the angle alpha. That's going to be equals to y minus 5. This is the difference of the y coordinate divided by sine of the angle alpha. And this is going to be equals to the distance between the 2 points, which is R in our case. So where R corresponds to the length of the line segment AB. So fine. Now what we can do here, our next task will be to determine the value of cosine alpha and sine alpha. Now to do that, we'll take the help of the line L prime, because the condition here is given that the AB, this line segment AB, is going to be parallel to the line L prime. So that means whatever is the slope of this line, that's going to be the slope of AB as well, because parallel lines have got equal slope. So let's try to find out the slope of the line L prime. So what do we have? The equation 3x minus 4y plus 8 equals to 0. So what we can do here is we can rearrange the terms, and that's going to be 4y is going to be equals to 3x plus 8. So we have y equals to 3 over 4 times x plus 2. So this is the equation which, when compared with the slope-intercept form of a line, we have slope of the line L prime that comes out to be equals to 3 over 4. But we can use the fact here, but we can say that the slope of L prime, that is going to be the same as slope of AB, which implies that the slope of the line segment AB, so that's also going to be equals to 3 over 4. So now that we have the slope, now slope is also defined as tangent of the angle alpha, where alpha is the angle that the line makes with the positive x-axis. The tangent of alpha, that's 3 over 4. Now that we have tangent of alpha, can we not find out sine alpha and cosine alpha? Yes, that's a very simple task. So we can find out sine alpha. So sine alpha comes out to be 3 over 5, and cosine alpha, that comes out to be equals to 4 over 5. So now we have sine alpha as well as cosine alpha. We will substitute this back into the distance form of the line segment AB. So we should get x minus 2. So we again working with the line segment AB. So we have x minus 2 divided by cosine alpha. So that comes out to be 4 over 5. That's going to be equals to y minus 5 divided by sine of alpha, which is 3 over 5. And this is going to be equals to R. So here we get two equations. One of the equation is going to be x minus 2 over 4 over 5. That's going to be equals to R. Or we can also say that y minus 5 divided by 3 over 5, that's equals to R as well. Okay, now let's do one thing. Let's find out x and y from here. So x comes out to be equals to 2 added to 4 over 5 times R, and y comes out to be equals to 5 added to 3 over 5 times R. So here what we have done, so we have found out the coordinates of point B, which we initially considered to be x, y. So here we have successfully converted them to the parametric form. So x coordinate that has the parametric form 2 plus 4 over 5 times R, and we have the y coordinate expressed in terms of the parametric form is 5 plus 3 over 5 times r. But this is the parametric form of the coordinates of point B. The advantage of converting the coordinates of point B into its parametric form is because now we can take help of the fact that since we have this point B, we have obtained the coordinates of the point B, so it lies on the line L, whose equation is given 3x plus y plus 4 equals to 0. In other words, we can say that these two coordinate values are going to satisfy the equation of the line. So let's make use of that fact. So here we're going to consider the fact that since the point B that is going to lie on the line, we have the equation 3x plus y plus 4 equals to 0. So what we have here is we get 3 times x. So what is x here? X is simply 2 plus 4 over 5 times r added to y. The y here is 5 plus 3 over 5 times r added to 4 equals to 0. So we get a new equation, and when we solve this equation, we will be able to obtain the value of r. So let's do that. We have 6 added to 12 over 5 times r added to 5 plus 3 over 5 times r plus 4 equals to 0. So that is going to give us, so solving for r, we get r equals to -5. But we know that distance is positive, so what we'll do, we're going to consider the magnitude only, which gives us r value equals 5 units. Or we can say thus the distance AB, which was r, that comes out to be equals to 5 units, and this is the final value.